Leslie. I will be your host today. Welcome to everyone in this room, and I would also like to welcome everyone online. We'll be listening to Eva and Bing, and they are going to give us all the ins and outs on effective master data management. If you have any questions during the presentation, please keep them. We will have a Q&A session at the end, so we will go over all the questions. And for the people online, you can use the Q&A function to ask your questions. Yeah, so the floor is yours, Eva. Go ahead.
Thank you. Thank you. Okay, so today we're going to talk about MDM and effective way to tune your MDM role and kind of improve the performance. Okay, so who are we? I'm Ava. I'm one of the managers at Smile Digital Health, and Bing is joining us from Toronto. I think it's 4 a.m. there, so thank you for joining us. So today, we're going to talk about HAPI MDM, why MDM is important, how to improve performance and tune your MDM role, and how machine learning is really helping us tuning our MDM roles. So, what is MDM? MDM stands for Master Data Management. It is a comprehensive approach and set of processes, policies, and technologies used to manage an organization's critical data assets, referred to master data. So it's basically finding duplicates. So these two guys are the same, so we want to basically find duplicates in our systems. So the primary goal of MDM is to ensure data consistency, accuracy, and integrity by establishing a single source of truth of master data. In HAPI MDM, we call it golden resource. MDM helps in eliminating data redundancies and all the good stuff. So why is HAPI MDM important? So MDM helps improve the quality of healthcare data by really resolving duplicates and matching them, which is leading to cost efficiency. Data integration, that's very important, and that's another thing that MDM does. And it's very important when it comes to patient safety. Imagine a lady in labor gets admitted to the hospital, and we really have to find her records all over the place, making sure there's no allergy or no nothing. So that's why it's very important. What's unique about HAPI MDM is we really support different resource types. As long as they make sense, you can configure your MDM to use patient, practitioner, organizations, immunization, etc. HAPI MDM also supports customization. You can always use interceptors. Interceptors are custom Java or JavaScript that are used to modify the behavior. We usually use point cuts. It's basically points in your code where the program cuts over to do a custom thing and then comes back. And you can do the customization prior triggering MDM, while MDM is processing everything, and even after. So now how do we improve our MDM role that can really identify the duplicates so we can match the bees to the prints? To give you an overview, when MDM gets triggered, the MDM rule also gets triggered, and it has different parts. We do versioning, we have MDM types, candidate search param, candidate filter search param, match fields, and match result map. So these are different fields in MDM rule. Here's an example for it. It's too tiny for you guys to see. So, how to tune MDM rule and improve performance? You really have to choose the right candidates and set filters. Pick the right algorithms. Define the result of successful match by combining the right entries. And also, you need to define what information will survive on the golden record, which is out of scope. HAPI doesn't support that. In SMILE, we have something called survivorship, and that's where you can configure what will survive in your golden record, but I won't cover that as part of today's session. So when MDM gets triggered, as I said, MDM rule will get triggered. And basically there are 3 steps. I will go through the first one, which is applying filters. So you have 3 fields, MDM types, defining those, candidate search, and candidate filter. So this is like a list of pre-searches that find potential candidates for matches. So here in MDM types, you can say, you can define what you want to look at further in your MDM and really setting filters. Here I specify organization, patient, and practitioner. So when immunization comes in, I'm not going to find a match for it because I didn't define it here. I will create a golden record for it right away. So let's talk about candidate search and candidate filter search param in a little bit more detail. So candidate search param selects a subset of resources that can be part of matching exercise. These can be set as loose, to have a large set of participants, or tight, to have very limited selection criteria based on customer data and performance requirements. So if you look here, candidate search params, again, that's another way to set filters. Here I have a resource type patient, and then phone number. So when a patient record comes in that has a phone number, I will consider them, I will add them to my pre-searches. So later on, I will see if I can find a match for it. Same thing here. One thing to have in mind, these are, so you add the OR logic between each of these fields in candidate search param. A way to have AND is just defining an array. Like here I have patient identifier and patient birthday. So when a new record comes in and it has a patient identifier, but it doesn't have birthday because it's, there's an AND between them, I consider them a new record, right? Candidate filter search params. Again, another way to add filters. Here you can see you have to define the value for candidate search params. And the good thing about them is they add the AND logic to any resource types that you define here. So for example, here, I defined resource type patient.phone and active has to be equal to true. And here I have patient identifier and birth date, and I add another and to it. Defining pre-searches and filters are very important and can boost your performance. Also, it can kill the performance if you don't choose them correctly. So, for example, if you define a candidate which is too outreaching and is too common, you will kill the performance really. So you really have to be mindful of what you are choosing. Same thing with candidate filter search param. It can filter because of the and that it will add to all the fields that you're gonna define, but also it can also kill the performance. Like gender is a good example. Most records, they come with a gender, and that's not a very nice way to filter things out because it's too common. So basically, you will run lots of queries and you have to fetch all the data in advance. So that's not a good filter. Defining custom search params and adding it to candidate search. So that's another way of boosting the performance. It can also kill the performance. So you always have to find a balance. Custom search parameters, you define them as part of the startup. It will start indexing everything. So again, it can be very useful because once you use that variable, the custom search param that you define in your candidate search, it like everything is already indexed, so you can boost the performance that way. But again, if your customer search param is not well defined, it will kill the performance as part of the startup. Okay. Let's talk about applying comparisons and algorithms. So that's the second stage. Once you define your filters, now you apply comparisons and pick your algorithms. So we have different types of algorithms, and we're going to talk about how to find the right algorithms and how to set right match thresholds. So we have two different types of algorithms. We have similarity and we have matcher. So similarity, it's similarity algorithms, we score them from 0 all the way to 1. And for matchers, it's like 0 or 1. You can always refer to HAPI docs if you want to take a look at the algorithms, and more information, you can find them there. Okay, so how to find the right algorithms? Test. If you're not testing, do not come close to me. You really have to test your MDM rule with your database. We always stress how important it is to go through a robust testing and tuning for your match rules and performance. No two demographics are the same, and no two architectures are the same. There is simply no way to get around doing the work if you want the MDM to work for you. Choosing the best algorithms are a little bit touch and go. Generally, we can't really tell you what is the best algorithm for your database. As I said, it really depends on what your demographic look like. Okay, but there are some rules you can follow to figure out what algorithms are best for you and how to come up with the best match result. So data fields. Data fields, you have to, again, review the demographic fields available in your database. For example, if you live in a country that accepts lots of immigrants, Then you want to use our Metaphone or Levenstein algorithms when it comes to first name, last name. Because, for example, my name is, I spell it AVA, I pronounce it Ava. Some people, they pronounce it Ava. So it's very hard, it's very easy to mess up the spelling of my name. So you really have to use right algorithms when it comes to first name, last name. Data quality. So again, you have to assess the quality and completeness of the demographic data. So if you work in a hospital and there are lots of identical twins with like crazy names, baby boy, baby girl, again, we are not judging, but these are the default values. But if you want to name your girl, baby girl, we're fine with that. But you have to use right algorithms. You have to see if there are some inconsistencies or you are missing data, then maybe you want to lean into similarity algorithms and use Levenstein, like if people are fat fingering or something is missing. Again, how variable your demographic data is, and sensitivity and specificity. So again, that's very important. You have to find a balance between false positives and false negatives. Again, MDM won't guarantee that we'll find all the duplicates, but you have to try to minimize the false positive and false negative rates. Okay, and last stage is get match and possible match results. So there's a field called match result map, and there's a combination of fields that you define, and you would define the result as well. So it, again, really depends on your database. Here you can use the variable that you define in comparison and algorithm stage. Here, I think this person used Metaphone algorithm. That's why the variable is called first name meta. And then I think Jar Winkler, they use that one. So it is important to define possible matches when it comes to working with health data. Sometimes it's okay not to be 100% sure. So you can always define possible matches, and you don't have to manually update the data or manually set the match result from possible, change it to match. When new data comes in or data gets updated, MDM rule gets triggered again. And if you selected right combination, it can change a possible match to a match. More specific ones will be covered by the more generic ones. So again here, if I just mentioned first name meta, last name meta, and my second field will be, second entry will be first name meta, last name meta, birth date, the more generic one will cover the specific one. So I always recommend creating a table for yourself, write down the variables and then just check marks and make sure you don't come up with like duplications or just get rid of the specific ones. So I'm gonna pass it to Bing. Bing raised his hand. I don't know why. This is a collaboration we did with U Waterloo team because, again, as I said, it's very difficult to and time consuming to tune your MDM rule. So machine learning is doing a really good job helping us tune our MDM rules. I'm gonna pass it to Bing.
Yep. Can you guys hear me?
We cannot hear you. I mean, I can hear you because I'm so close to you.
Oh.
I have to put my sound on. What is that?
We're gonna have to
Okay.
from here. your sound on normally when he talks?
Would it also be possible to pass me co-host as well, so I can share my Visual Studio Code when it comes time?
I couldn't. Here.
He should hear you. Yeah, put it up.
I can.
Can you just put your sound up, or is that not possible?
Let me go through here.
Share computer sound, yeah. Yes. Yes. Unmute. It was unmute? I'll wait.
Sorry, guys. Okay, say something.
Can you guys hear me?
Yeah, if you can put it over there, then I will. If you put that phone, then they can hear you. Otherwise, the people in the internet can hear them. But
Okay. Try now.
Can you guys hear me? Test.
Try testing again.
Test. 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 Test.
Yeah. No. Okay. Can you yell?
Can you hear me? Can you hear me? Test. Test.
Yeah. Test. Okay, this is working, but somebody needs to signal. I can call him from my phone. Hmm? Speak up. Thing.
Yes.
Yeah.
Can you hear me?
I
Hello?
can, yes, but they can't.
Okay, so what do you want to do? I can send you my script on Slack, and you could just say it over there.
Oh. Bing, start talking.
Yes? Yes? Can you guys hear me?
Only from the computer.
Only from the computer.
Okay, let me call you from my Slack. I called you from Slack.
We only have like 2 minutes left.
Okay. Guys,
Can you hear me through this?
No, we have to.
This is better?
how did you turn it on? Oh, it's on. Speak up now.
Does this work?
Can you speak through Slack? You're muted on Slack.
Use your laptop. This one? Yeah. Can Bing talk now?
Bing, can you talk now?
Does this work? Hello? 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 How's this?
Okay, much better. Sorry. Go for it.
Okay. Okay. So I'll go quickly through my slides. So I guess for the first slide, what is machine learning? So machine learning is a subset.
One second.
Yeah. Yeah.
Then I can turn you on here.
Right.
Now we hear you there.
Okay, he's muted everywhere.
No, not so.
Yeah, this.
No sound on the laptop, no sound on the laptop.
Okay.
Yeah.
No sound.
Is it working?
You have to
Is this okay?
press on the sound.
So speak through Zoom.
Okay. Let me connect to Zoom again.
Okay.
He left the Zoom chat. So he's going to, the sound is going to be from.
I don't see him talking by Zoom.
Yeah. He's unmuted.
Yeah, he's not talking. I don't see anything coming into the. Is he saying something in Zoom now?
Recording in progress. Let me message him. He's raising his hand.
Is this better?
Okay, be super fast.
Okay. All right. What is machine learning? So machine learning is a subset of AI, and instead of explicit programming, ML uses algorithms that analyzes a large amount of data, learn insights, and can make informed decisions. So ML and AI can be integrated into HAPI FHIR to allow more algorithmic leveraging of data analytics. So the next question is why use ML for MDM? So starting off with a few cliffhangers. Through active learning, ML can help clients match more records with Smile. And with more records being matched, learn better patterns for matching records in the future. And at the end of the day, the most important thing is we can help clients match records even more efficiently with ML. So let's look at some examples of ML in action to help people match records. So something that's hard for people working with MDM is setting the right thresholds. In this case, what is the best threshold for Jaro? Small MDM FHIR experts like Ava can roughly guess good ballpark values that would work well, but are not necessarily optimal. So if you can click again. So ML can let's go back to the previous one. So ML can automatically find the correct match thresholds that optimally matches the data. And if we take a look at these thresholds, it's not something that, that a person would try. So next slide. So something else that is difficult for people is knowing how to configure the match result map. So looking at this, a person might ask, are all of these rules really necessary? Or are there some better rules that I can use? So ML can answer both of these questions. With ML, we can automatically remove unnecessary rules as well as automatically use better rules. So I've shown you guys the previous two examples, but how do those examples work? Well, the critical insight here is that the match result map can be represented by a special decision tree called a prefix trie with some other qualities as well. And any match result map can be converted to the special form of a prefix trie, and any special form of this prefix trie can be converted back into a match result map too. So with this special form of a tree, you can apply decision tree optimization, and you can basically find your most optimal match result map by changing nodes, by pruning rules, and by adding new rules. So zooming out to a larger view of the architecture, the current and next deployment represents the workflow of a MDM client. So first, you have your client private records, and they're fed into this MDM policy. And from the policy, we have the annotators who will make decisions. And finally, you get your client annotated data. And this is the client annotated data represents golden records. And the ML lives between your current configuration and your next configuration. So how the ML works is it takes in the configuration file, it takes in a bunch of data, it applies 9 different algorithms from your choice, and it produces a optimal next configuration for your JSON file. And the really cool thing about this is you can repeat this process as many times as you like. So now let's get to the bottom line. Does this actually perform better? Well, from some of our initial testing, we can compare typical manual MDM configurations with the ML optimized ones. And as you can see here, the performance increases as more sophisticated machine learning is used. So for the match result map one, if you can click again. Yep, so for the match result map, performs decently, but for the next demo, I'd like to show the voting assembling. So let's go back to the previous slide, sorry. So we probably won't have enough time for this demo, but just to kind of give an overview of what voting assembly looks like, voting assembly basically combines prediction from multiple different models. And in the demo, we combine logistical regression, random forest, as well as Gaussian naive Bayes. And the way it works is it takes outputs from all of these 3 different things, and it gives you a majority rule. So basically by voting. And in the demo, we show that the ML models are able to automatically learn the MDM patterns for defined fields. And finally, all of the learned model information can be saved to use for deployment. So for the next slide.
Bing, you have 3 minutes left.
Yes. Okay. So just to quickly summarize, ML is able to find accurate patterns by removing tedious manual configurations for clients using HAPI MDM. And through using ML, we can help HAPI MDM clients find matches faster and more accurately beyond just manual configurations. And finally, at the end of the day, using ML for MDM will allow more matches to be completed by HAPI MDM, which is at the end of the day really great for FHIR. So thanks.
Right. First of all, thank you, everyone. Thank you, Ava and Bing, for presenting. Sorry for the slight hiccups. I hope everyone still got the story from Ava and Bing. First, I would like to go to the group. Are there any questions you would like to ask? Yes.
Thank you for the presentation. Ava. Oh, okay. I have set up HAPI, and we have implemented our own custom survivorship rules. Everything's great. Merging records. I would like sort of both get the idea verified and maybe address the elephant in the room here. When we get these golden records, the way I see it, it ends up being read-only model, because the only way that you can manipulate it is by manipulating the sources. Mm-hmm. So what I'm missing, or sort of would like some advice on, is how should we refer to these golden record instances, and should we even refer them at any point? So, for instance, if a patient has an encounter, the reference to the patient, should that be the golden record, or should it be one of the sources for the record?
So definitely the golden record, right? But then you can always, so the whole point of having a golden record is having that like single source of like truth, right? So, but then the links are fluid, right? So as new records come in or as you modify your MDM rule, all of these links will change to the golden record, right? So when you're talking about your resource, which is connected to the golden record, right, then you can find all the links and all the other sources through the golden record, right? So it's important.
Your advice would be to always refer to the golden record. Also, when it comes to these diamond constellations between practitioner role, practitioner organization, and if you have a golden record, you would refer to that in all cases.
Yes, because not only you have a survivorship rule set up, so you can always decide what needs to survive on the golden record, right? Sometimes there are like some specific allergies or something really vital to the patient, right? But then you can always find other link sources through the golden record. If you, my personal opinion, if you directly connect the source to other sources, then you will come up with a very fugly situation because what do you want to do? How do you want to manage the references? If one gets updated, how do you want to merge? Like what other methods you're using? It's going to get very ugly. Or if you want to, I don't know, you updated another source and you realize you messed up and this is not a match, then how do you want to all these other links, right? So it's always good to have links to one golden record and then modify the links instead of just creating more links.
I have a follow-up question, but we can take that later.
Okay.
Any other questions? Yes.
Thank you. Hi,
Hello.
thank you very much for the presentation. I really liked it.
You joined very late. Okay,
Not
but go.
really. I was there. I was listening. By the way, with the machine learning algorithms, what I ask myself is, first, the numbers are really nice. But the first thing that I always ask myself is how much overfitting was there? This means you overtrained your model, but when you let it run in the real world, you will get a much lower accuracy rate. And second, what I also ask myself is, can you figure out if a patient was matched to another patient, which were not the same? Can you figure out then why it was matched like that?
So first one, yes, exactly as you said, you shouldn't come up with a overfitting solution, right? That was one of the struggles when we started working with U Waterloo team. Sorry, Bing, to put you on the spot. The difference between industry and like university is that they're okay coming up with an overfitting solution. We are not. So yes, definitely not coming up with an overfitting solution. You always have to find a balance. MDM is not a super performant tool, or it's not a guarantee that it will find all the duplicates, but you always have to manage your false positive and false negative rates. And your second question was false negatives?
I matched it with this patient. Thanks. I matched it with this patient, and the clinicians are working with this patient and figure out, oh, it's the wrong one. Can you figure out afterwards why it was mismatched?
Yeah, so in Smile, again, I'm not here to talk about Smile. We offer you a UI. So again, there are some interns and co-ops out there who can like manually click and do all the comparisons. But you can also, I think there's an open source code. You can calculate the false positive and false negative rates. So always start by a set of records and test with those. As you're modifying your rule, you will change the algorithm. Also, you will start modifying the match thresholds. That's something that Bing was doing. So if you had a sets of records, then you know the result. Start with that. You know what to expect. So you can calculate the false positive and false negative rates. And then as you're getting better and you think your MDM rule is doing better, then you can expand the searches and you can work with like 1K and then 10K and like, a bigger set of data. Thank you.
Thank you, Ava. Yes.
Thank you, Eva.
Um,
I have 3 questions. I think the first one was already answered, but just want to make sure I understood it. The handling of referenced or referencing resources is not part of the, right? It's not the part of.
No.
Okay. Then the second one would be
Because in HAPI we do not touch the source resource.
you don't destroy it.
We do not modify it at all. That's why we modify the golden resources.
Okay, thank
Even
you.
when we do normalization, we do not touch the source resource. We recommend things, we do not touch the source.
Okay, my perspective is from an specification setting organization, digital health agency for Germany and hospitals. So we need a generic solution of the problem you solved at a practical level, but we have to solve it at a generic level for like a couple of specifications in hospitals actually. So we were looking for core FHIR operations, which could be useful, like patient link, match in R4 and merge in R5. And the actual question is your solution conformant to these operations, like match in FHIR R4 or merge in R5?
I haven't seen anyone reporting any restriction with different versions, but I can definitely test that out, and I can, because I have MDM set up, I can answer your question after this session. I can test it.
Would be great, thank you. And the last one, just a really basic question. You presented the use case for inter-organizational exchange, so hospital A to hospital B. Would your solution fit also for intra-system organizational communication, like between subsystems and hospital information? So it's yeah. Okay,
Yeah,
so it's kind of an MPI also, master patient. Okay, thanks.
This is exactly like EMPI, but better.
Thank you for your questions. We have 2 minutes left to answer questions. So if anyone has a question to ask, yes. Anyone that? Oh.
Okay, I'll do the follow-up question then.
Okay.
So assuming we have this, we have the system set up, MDM runs, everything's great. Now we have a third-party system integrating to us. Let's say they'll submit encounters and patients.
Same resource types?
Yeah, the same resource types that we run MDM on. And they, for all kinds of reasons, would like to refer to their own patient IDs.
EID?
Not the EID,
No,
their own IDs.
Oh, patient identifier? Okay.
No, not the identifier, the patient, the literal ID.
Okay.
So what happens when they send an encounter to this setup where you have MDM, they refer to the patient using their own IDs. And then all of a sudden, MDM would substitute that ID, I guess, probably using, now I'm going into thin ice, because here we would then manipulate the patient ID on the encounter, right? Because from our own point of view, we would like golden records to be referred in all cases, but third party is not interested in the golden records. So what would be the recommendation here?
So again, do you have golden records? Because we can resolve this after MDM rule in the survivorship. So if there's a new field getting added, right, you can use the merge all or merge specific fields, and you would do the matching and nothing is changing there. But in the survivorship part, you're like, oh, new field is getting added to this patient record and I'm gonna merge. So I will add the new information to the golden record. But you're saying in your case, you don't wanna have a golden record?
I would really much like to have the golden record. I just think there's a case here where you will be sort of forcing or imposing restrictions on third-party systems having to understand golden records to the system that they send to, which is sort of a new kind of requirement, that their references will be substituted eventually, and they cannot just update their own data that they've previously updated in the system, because IDs will be substituted as part of MDM.
Golden records shouldn't necessarily be visible to the clients, right? They can always run MDM operations and then like MDM query links to find all the links, right? So if they're not interested in golden records, then like it's okay for us not to make it visible to them. But again, they can always use EID mode instead of just going through all the matching and survivorship and whatever. They can have one unique identifier. They're responsible for providing it. As the incoming data comes in, EID has to be provided. We call it external EID. In case of what I explained, that was non-EID mode. So when there's no external EID, HAPI generates one, and we call that internal EID. So if you have external EID being provided by the client or that hospital, then you can do the matching based on that external EID and you're good to go. They don't have to be worried about anything.
Okay, thanks.
Thank you.
I hope that answers your question, but
He
looking at
looked a
the
little
time,
bit
yeah,
disappointed,
but you can maybe follow along this discussion after the presentation. I would like to thank everyone for joining this presentation, and have a good day. Thank you, Eva, and thank you, Bing, again.
Thank you, the IT guy.
And once again, sorry for the hiccup. I hope the story was still clear.